In this lesson, you will learn the different authentication schemes in web applications. So let's start by going over what is authentication and what is session management. Authentication is the process of verifying that whether it's an individual, an entity, or a website is whoever actually is claiming to be, right? So authentication is in the context of a web application is commonly performed by submitting a username or an identifier, an ID, and one or more items of private information like a password, some key, some token, some pre-shared key, and so on. Now, session management is how a server maintains the state of an entity that is actually interacting with. This is required for a server to remember how to react to subsequent requests. Sessions are maintained on the server by default with an identifier, with a session identifier. And this session ID is actually passed back and forward between the server and the client when transmitting and receiving requests, right? So sessions should be unique, of course, per user, and also they should be computationally very difficult to predict. Now, a web application scheme is a method or a recipe to pass those credentials from a user authenticating, to a system, right? So from the user to the actual authenticating system. Now, these schemes vary in their security and complexity. Some of can only handle authentication, and other ones can actually handle both authentication and authorization. Now, SSL, or Secure Socket Layer, or TLS, Transport Layer Security, is typically used to ensure confidentiality, and that's actually a required prerequisite for a lot of the authentication schemes to rely upon, right? So at the end of the day, nowadays, all modern applications should be actually using TLS and a strong version of TLS, and we're going to go into that later in the course. Now, the following are some of the most common types of web applications authentication schemes. So we have TLS and of course, SSL, and that is not only doing the authentication of the server, but mutual authentication. So that means authentication, client-based authentication as well. And we're going to cover that in a few. Now, HTTP basic auth is another one. HTTP form-based authentication is another one. DAA, LTPA, or lightweight third-party authentication, OAuth 2, OpenID Connect, and SAML, right? So those are the most typical authentication schemes out there. So let's actually start with TLS, right? So TLS, a lot of people actually refer to as SSL, right? So, but at the end of the day, is modern versions of TLS, so 1.3 and above, is actually the central concept of protecting in authentication schemes, right? So the central concept is in TLS is actually the detail certificate and how they actually form a chain of trust. Now, a digital or a public key certificate is an electronic document that is actually proving the ownership of a public key. The certificate contains details about the key, the owner information, and the digital signature of a certificate authority who vouches for all the different contents, right? So now the digital certificates and certificate authorities, or CAs, are central to public key infrastructure, right? Now, every web client has a default collection of certificates from a major certificate authority. So your browser will have a list of a collection of trusted certificate authorities that are very popular out there, right? Now, each certificate is actually signed by a single authority, and in turn, the certificate of the signer is actually signed by another authority, each becoming more widely accepted. Now, finally, the root certificate of the chain is self-signed and is widely distributed. This root certificate is actually the anchor of the trust in that PKI environment, so the public key infrastructure environment, and it's actually used to validate the entire certification tree, right? Now, any certificate can be trusted if it has been signed by a CA, or a certificate authority. Now, by far, the most common use of digital certificates is establishing an SSL or TLS-based channel of communication. Now, SSL authentication can take two forms: simple, and mutual, right? They also people refer them as the one-way or two-way authentication. In one-way authentication, usually is whenever an HTTPS connection, right? So from your browser to a secure server is established, right? So in that case, actually, there's a one-way SSL authentication, if you will, right? Because actually, the client is verifying the DDoS certificate of the server. Now, if the certificate of the server is not found, but the signed certificate that the client actually does trust is found, then the client actually also trusts the server. That's what we call the chain of trust. Now, in mutual authentication, everything that occurred in the first or the one-way interaction still will happen, right? So those 9 messages are exchanged, but also the server requests the client to present a certificate and to actually check its own collections of trusted certificates to determine if it actually can trust the client. So that's the concept of mutual authentication, right? Now, there's another method, if you will, called TLS SRP or TLS Secure Remote Password. It was actually introduced as a means to provide a password-based client authentication to the server without the need of certificate. It actually addresses the usability issues, managing certificate clients, and you don't have to actually worry about the dual mutual authentication of certificates and how they actually are exchanged or maintained and everything else. But technically, TLS SRP was never widely adopted, and it actually suffers from being accepted. So you barely actually use it nowadays. But just be aware that there's another method called TLS Secure Remote Password. So whenever you actually are doing your assessments and your pen testing, you may encounter some of these, right? Now, going to the traditional authentication methods, you also have the basic HTTP authentication, right? So that's the authentication. Actually, you see pop-up messages from your browser that are barely used nowadays. They have no cookies, no handshakes. It's really basic authentication. It actually uses a dedicated HTTP header to actually communicate the encoded username and password on every request that is authentication. So that requires the client, so your browser, to actually cache the credentials for a period of time. Otherwise, the user will actually be prompted to log in repeatedly, every time. Now, since the credentials are basically transmitted in the clear, that's when you actually have to pair it up with SSL and TLS, right? Now, it is simple to use. It's simple to understand. You actually have, those, features, for basic authentication or basic HTTP authentication, but it has several drawbacks, right? So there's no standard way to log out. There's no way to customize the login experience. The client needs to prompt users for credentials, collect and encode those into the header, and this is actually done by the browser, by the way. And then the client needs to securely cache credentials for a reasonable period of time. This also fundamentally insecure since the full credentials actually are passing over the wire, and that's the reason that you actually have to put TLS on it. But again, hopefully you don't encounter some of these. There's many different problems, especially in the implementations, and not so much in yes, the technology actually has a lot of drawback, but a lot of people actually have implemented very, very unsecurely in the past. Now, there's also HTTP form-based authentication. So, in other words, an HTML form that is actually probably the most popular form of authentication, because it's actually simple as well, and it allows the login experience to be completely customized, unlike basic authentication, right? So, this technique is actually simple, like as I mentioned before. Basically, just prompts the user for a username and password using a custom HTML form, and then it sends those credentials to the server in the next request. So there's no standardization implementations, and all of them are actually done ad hoc. Now it requires, so this HTTP form-based authentication requires the use of SSL and TLS connections, of course. If not, definitely the credentials are going to be sent over the clear, in the clear text. So you don't want to do that. Now, there's another format or form called the Digest Access Authentication, or DAA. And that was created to address the fact that basic authentication sends the full credentials to the server. And in this case, DAA, or Direct Access Authentication, only sends an MD5 hash to the server. It actually includes some additional features like a nonce and protection against anti-replay attack. However, you want me know that MD5 is not secure, right? The just access authentication schemes within MD5 is considered insecure, and this is because it has a whole bunch of collision attacks that can be possible, and of course it's a weak hashing algorithm, right? Now there's another method called the lightweight third-party authentication, or LTPA, and LTPA is actually an IBM proprietary method that was created to do single sign-on, right? It actually has to be used in conjunction with another authentication technique to initially authenticate the user, and then once the user is actually logged in, then the LTPA token, or the cookie, is actually created. Now there's another method which is very, very popular nowadays. It's called OAuth 2. So of course there's a predecessor, just OAuth, but strictly speaking, OAuth 2 is actually an authorization scheme. In other words, before beginning the actual OAuth process, the consumer application must first register with the provider application, and this is actually a manual one-time process that typically involves providing some basic information about the application, like the name, the website, some logo, it all depends, right? So there's also a redirect URI that can actually be used for redirecting the user from the provider back to the consumer web server, a browser-based or mobile app, right? So all of them, actually use this type of technologies, and that redirect URI must be provided to prevent certain attack vectors. Now the sequence starts with the consumer making the OAuth 2 resource request to the provider. The provider application actually informs the user of the request and prompts them to authenticate if they actually have not done so. Now the way that the provider authenticates the user has nothing to do with OAuth 2. Any authentication schemes actually can be used once the user is authenticated and has granted permission to the provider application. It actually the control reverts back to the consumer, and that's actually done via the register redirect URI. And now you have actually an access token that allows the application to access the resources in the provider. Now this access token is actually provided in the HTTP header for subsequent request, and the specifics of this interaction between the consumer and the provider, it depends on the whether there's several server hosted web sites, or browser based applications or mobile applications, right? So each of them have their own implementation. Now what makes OAuth notable is the fact that the user's credentials are never exposed to the consumer application. The consumer is actually only given a temporary token that actually expires. That's the reason that it's temporary, which can also be revoked by the user or the provider application at a time that you don't need those anymore, right? So, and of course, that's what you actually see a lot in the APIs nowadays, using OAuth 2, and if those tokens actually don't expire, or for some reason the implementer or the developer, they put the expiry, let's say for a year, that is actually a very unsecure method. So whenever you're actually doing the pen testing engagement, look at that. Look at how the application is whether expiring or not expiring, or how the actual credentials are being exchanged or not exchanged using these methods, right? So not only OAuth 2. Now going back to OAuth 2, it actually mandates that you have to use TLS. Now there's another method that is also used nowadays called OpenID, and it's basically an open standard for providing authentication of an identity. There are many OIDs, identity providers out there, things like Yahoo, Flickr, Google, WordPress, and many others, right? That they actually use OpenID. Now, any client that outsources authentication to one of these identity providers are actually known to be the relaying party, or the RP. Now, the OpenID specification actually has a set of extensions. One of them is called the Attribute Exchange extension, and it was actually done to profile attributes like the name and the gender and some other identity elements to be provided from the OpenID identity provider to the reliant party, so to the RP. Now, essentially, OID allows, or OpenID allows a user to maintain a single profile with an OpenID identity provider of their choice, and also to authenticate with any third-party website or a mobile application that actually participates as a relaying party. Now, the last method that I'm going to be covering is called the Security Assertion Markup Language, or SAML. A lot of people actually refer to as SAML. It is an XML-based open standard that is maintained by Oasis. It's actually used for both authentication and authorization, and it's also capable of exchanging user profile attributes as well. Now, previous versions of SAML relied on SOAP over HTTP, but newer versions, so from version 2.0 and onwards, it has a little bit more flexibility because it supports flexible bindings, and if exchanges are between the user and the identity provider and the user and the service provider, then SOAP is actually not necessary, right? So SAML 2.x and later and OpenIDC are actually different solutions to the same authentication and authorization challenge, right? So now SAML and OAuth 2.0 can actually coexist. Now, nowadays, a lot of APIs actually standardize in using OAuth 2.0, right? So a lot of people actually use that. And SAML is actually the current leading standard for interdomain web single sign-on, or web SSO. If you look at it, SSO, whether it's OpenID or SAML for sure, those are the most prevalent ones. In the case of modern APIs, you see a lot of OAuth 2.0. So whenever you're actually doing penetration testing, one, become familiar with those standards, become familiar of how applications actually may use them, may not use them, and so on. And later in the course, actually, we're going to be covering several techniques on how to even test some of these modern applications, and what tools to use and what flaws you can take advantage of in your penetration testing engagement.